Hello everyone, welcome to SM Today we are going to solve another LeetCode problem. Today's problem name is longest increasing path in a matrix. So basically we will be given one m cross n integer matrix and we need to return the length of the longest increasing path in the matrix. So if you check the example, you can see that here, if I start from 1 and then if I go to the left side, then 2, then up. So this is the path, the longest increasing path. What that means? So suppose 2 is greater than 1, right? Again 6 is greater than 2 and 9 is greater than 6. So this is a path or increasing path, we can say. So there can be other paths also, right? So like 169 is another path. If I go 169 or 126, these are the path in increasing, these are the increasing path, okay? So but we need to return the longest one. So in this case 1269 is the longest one. I think the problem description is pretty straightforward, so let's try to see how we can solve the same. Okay, so this is our example, right? So what we will do, we will try to, we know that we will try to use the DFS. So you know that DFS, right? So DFS means it's depth first search. So depth first search means we know that we will start from a particular cell or point and we will try to traverse till our depth, right? So until and unless we are reaching to the end, till then we will keep traversing, right? So here in this case we can see that, so suppose if I start with 9, right? So now from 9 I can know that we can go 4 side. We can go either left side, we can go right side, we can go down, or we can go up, right? So here in this case from 9 we can go only either in downside or right side only, right? So if I go downside, my value will be 6. If I go right side, my value will be 9, right? So now we should not traverse here 6 and 9 because 6 is lesser than 9 or my current value. Similarly, again the right side, again it is 9, it is not greater than 9, so we should not traverse, right? But so using this approach we can easily solve it. So let's suppose and we will keep doing this for each and every cell. So we will keep running our DFS for each and every cell. Okay, so suppose if I come here, right, 4, so suppose my node is 4 and we want to run DFS here. So how DFS will work? So again for 4 we have couple of options. Either we can go left side. In the left side, if we go, its value is 9. We can go downside. If I go downwards, in this case my value will be 8, correct? So again I will come to 9, and so I told you that DFS means depth first search. So I will traverse till depth for the left side, then again I will try to do for the right side similarly, right? Now again I will come to 9, this 9, right? Again I have 3 options now. I can go left side, that is 9. I can go downside, that is 6. I can go right side, that is again 4, right? So using this, so again I can see that I can't go anywhere, right? Everything is less than 9. So like this, we need to. So again, I will try to traverse like this, right? So at first we will traverse one portion, then again I will backtrack, and then again I will try to explore the other portion of the tree or matrix, you can say. Okay, so this is how DFS works. So let's try to see can we solve the same using the simple DFS approach, right? So what I told you that we are going to use DFS. So we need 2 variables. We will take basically length. So at first, before that we can check some edge cases condition. If I see my matrix is equals to null, then we can return -1, okay, or we will take 2 variable m and n. So let's take the same. So it will contain basically the matrix length. It's a 2-dimensional array, right? So this we need another variable. Since it's 2-dimensional array, we will take another variable n. So we are solving it using Java today, okay? So it should be matrix 0 dot length. Now I know the 2 length. Now apart from this, I need one variable, result variable or length variable, where we are going to store the result or the longest path or length, okay? So let us name it as result only 0, and we will return this result at the end. So we will return result, and now I need to run the DFS for each and every cell. So we will run again nested for loop. Since it's a 2-dimensional array, we will start I equals to 0. I should be less than equals to my length, then I plus, correct? Now again I need another for loop. Again in this case I will take j, and j should be equals to 0, j should be less than n, and j plus, okay? So that now I can pick one cell. Now I will run my DFS. I will declare one DFS function or implement one DFS function later. And in this DFS function, basically, so suppose what I am doing here, we will start from 9. We will go to the till depth. Okay. Again, once we are done, then again I will check it for the second set. Okay, so like this we are doing. So whenever I will traverse, we will keep checking the length, and we will keep updating the length in our result variable if it is longer than my earlier length. Okay, so my DFS function will do that. Will give us the length. Okay, so we need to pass couple of things in our DFS function. We need to pass the matrix. We need to pass the index of the starting cell from where we are starting the DFS, I and j, and we need another variable length, the current length, right? So suppose I will come here, in this case my length will be now 2. Okay, so these are the three values we need to pass. Okay, so now let's quickly define our DFS function here. So it is going to be a private method, and we are not going to return anything because we will update this result value only, and we are returning this result, so we don't need to return anything, so it will be void. And we are passing 3 parameters here. So first thing is our matrix. Okay, and second one is we are passing the 2 index int I and j of the current cell from where we need to start our DFS, and we are passing the current length. Okay, so let us name it as current length. Okay, so these are the 4 arguments that we need to pass. Now what I will check that, so suppose I am here, right? I am here. I will check whether I will check this in this case. Suppose if it is 10 instead of 6, think it like 10. So we have 2 path, right, or 2 cells. So in this case my length is 2. So I will update that length in our result variable if it is larger than my current length. Okay, so we will check that logic first. So what we will do, we will update our result variable first. So I will take the maximum value of my earlier longest value, that is should be in the result, or my current length. Okay, whatever is max, we are going to consider that. Okay, fine. Now this is done. Now just we need to call the DFS. So DFS means we can go in 4 directions: up, down, left, and right. So we will do that. So to do that, we will take 2 more variable. Let us name it as dx, and so basically it will contain the value for traversing left, right, top, and down side. Okay, so suppose if I want to traverse upside, right? So again, in this case I need to update my x value or I value with -1 so that we can go upside. Suppose I want to traverse left side, so it will be 0. X will remain 0, but we need to increment our y value or decrement our y value, correct? Suppose I want to go downside, then again we need to increment my current value with 1, and again if I want to right, then my x will still remain 0. So similarly I will take direction for y direction also, so it will be dy, and for suppose if I am going to upwards, my y will not change. If I want to go left side, I need to subtract by 1 my y value. If I want to go downwards, my y will remain same, and if I going to go right side, I need to increment my y by 1. Okay, so this will basically contain the direction. So once it will be 1 -1 0, then 0 -1, then 1 0, then 0 1. Okay, fine. Now we will traverse. So we will take another for loop, and let us name it as k, and we will start from, and this will run for this 4 direction only, right? So it should be always k less than 4 and k plus plus. Okay, so now we will just call our DFS function. So let's call our DFS function. So before calling the DFS function, we should not go for all the direction, right? So we should go, so suppose if I'm starting from the first node, right, or first cell, we can only go either right side or down side, because if I go upside, there is no valid index, right? It will throw out of bound exception. Okay, similarly we can't go left side, so we need to check those boundary conditions also, right, before calling our DFS function. So I will check that if I see my before that we need to calculate the next cell value, right? So suppose I want to go next, so I need to get the index of this value, right? So let's calculate the index. So we can easily calculate the index, whatever my current. Suppose I am here, so here my value is 0 0, I is 0, and j is also 0, right? So suppose I want to go right side, then my I should be still 0, but my j should be 1, right? So we can get this value using this dx and dy matrix, right? So let's calculate. So let's calculate our x and y value, right? So x will be my current value, that is I, and my dx k value, right? So suppose I will go at first upwards, so my x will be I minus 1, so that means we are going upside. Similarly we will consider it for y direction also, right? So it should be it should be j plus dyk. Okay, so this will basically give us the direction x and y. So suppose I want to go here, in this case my x will become 1 and y will remain 0. Okay, so like this we are going to okay, so now we can check our boundary condition. So suppose if I see my x is still greater than 0, then it's a valid, and also I will check that my x is less than my length. Okay, so x should be less than my length, so matrix dot length, so that x is in our boundary. Okay, now again I will check that whether my y, so similarly y should be greater than equals to 0 and y should be less than our length. Okay, so matrix 0 length. Okay, fine. So, and these are my 4 conditions to check the boundary condition, and apart from that we should traverse here only if my next value is greater than my current value, right? So we can check this logic here only, right? So we can check, so what is my earlier value or earlier index is in I and j, right? So I will write like this: matrix I and j should be less than my next value, wherever we are traversing. So next value is x and y contains the index of next cell, okay, where we are going to traverse. So we will write like this: x and y, correct? So if these all 5 conditions are satisfied, then we can call our DFS function, right? So again we need to pass 4 things. The matrix will remain same. We need to pass index I and j. So here our new index is x and y, so we are going to pass that, and we need to pass the length. So whatever my current length, so suppose I am going to this here, right? So now my length become 2, so my earlier value, that is 1, now plus 1, so it should be current length plus 1. Okay, and now again it will keep traversing the way I showed into the note, right? So let's quickly run the code and see whether it's compiling or not. Okay, I can see it's compiling and it's giving us expected answer for the first solution. So let's try to submit the solution and see whether it is accepted or not. Okay, so you can see it's giving us time limit exceed. So these are our input, and it's a really large input, and in this case our solution is failing. Okay, because you can see that we are traversing again and again for each and every cell. So this is the correct way, but this will take much longer time. Okay, so we will try to optimize our approach so that we can solve it in lesser time. Okay, so what we are doing here, we are picking one cell and we are traversing all the possible combination, all the possible 4 side or 4 direction. So what we will do, we will try to optimize the same using some memory or extra memory, right? So for that, what we will do, at first we will use an extra memory, and in that memory we are going to store the result. So let's quickly take one array. So we are going to use extra memory. So suppose this is our extra memory. This will contain, initially every value will be 0. Okay, so everything will be 0. So let's quickly fill it with 0. Okay, so everything it will be 0. So whatever my m and n value, m cross n matrix, right? So similarly I will take another 2-dimensional matrix of length m and n. Okay, so now what I will do, so suppose let's see the example, right? So let's quickly rub this thing. We will see that how we can solve the same using extra memory. So yeah, so I'm done. So what I will do, so I will start from 9, correct? So 9 is my first value. So this is my first value, correct? Now I can traverse, as I know that I can traverse 2 sides, either down, that is 6, or I can go to right, that is again 9, correct? So I can see that it's not possible to go anywhere, okay, because the next cell value is not larger than my current value. So I know that from this particular starting path I can go 2 sides, right and down, and in this case I can't go anywhere, so my length will be 1, correct? So I will use this memory. So I know that from the first cell I can't go anywhere in that increasing length sequence, so my value will be 1. Correct, my value will be 1 for the first cell. Now I will go to the next line. Again I will come here 9. Again I have three option in this case, sorry. I can go left, that is again 9. I can go down, that is 6. I can go 4, that is 4. Okay, that is the right side actually, right? 9 6 4. Again in this case also I can see it's not satisfying our condition, so we can't go anywhere from this second cell also. Again we will update our value with 1. Correct, so second cell value will look like this 1. Now I will come to the fourth cell. Correct, for the fourth cell it will look like this. This is our cell, and from the fourth cell we have two options. We can go left side, that is 9. We can go downwards, that is 8. Correct, fine. Now so this is a valid sequence, right? 4 is smaller number and 9 is greater than 4, so this is a valid sequence, right? 4 to 9, this is the increased sequence. We don't know that it's a longest one or not, but it's, yeah, so it's a valid sequence, right? So I can go here also, right? Now we know, okay, 9. So what we are doing in earlier approach, in earlier approach we are again traversing or running DFS for 9. 9 means this second cell, right? But in this case we are using this extra memory, right? So I know from the second cell I can go, my length is 1, so we are going to, because we already traversed this path, we already traversed it for 9, right? So we should not traverse it once again and again. We are going to use the earlier result. So we know from 9 we can go to the we can get maximum increasing path length, that is 1 only, right? So we should not traverse anymore. So I know the result of 9, we are just reusing the result. So that is the use of this extra memory. So using extra memory we can remove some duplicate calls, right? Duplicate DFS calls. Earlier we are traversing blindly, we don't know that whatever, so probably we traverse already this path, right? 9, from 9 we traverse already all the possible paths. But in earlier approach, suppose I am 4, again I will traverse the similar path once again. But in case of using extra memory, we are saving those calls, right? We are not again traversing the path for 9. So again I know that from 9 I can go 6, I can go 9, or I can go 4. But we are not traversing the same, because I know the result of this subpart, right? So I know the result of this particular path. So we are not going to traverse anymore. So whenever I will see 9, I will check my memory or memory array that okay, I already traversed this path, and in this case if I start from 9 I can get maximum value is 1. So I know from the left, so if I for 4 to 9 I got the value that is 1 and plus my current node, so it will be 2, right? Correct. So from 4 if I go to the direction of the left, I can get the maximum path, that is 4 to 9, and the value is 2. Now again I will check it for 8. Correct, 8. So now I will come 8, and again I can see okay, we have not traversed any path of 8, because I can see that for 8 it is still 0, right? So again I will see what is the possible path from 8. So from 8 we can go either left side, that is 6, we can go downwards, that is 1, or we can go upwards, that is 4. Correct. So all values are smaller than 8, so there is no point of traversing here. So here there is no possible path, so I know that my value will be, largest value will be 2 here. So I am going to update our matrix, memory matrix, and the value will 2. So I know next time whenever I will see any path from 4, I can easily return this 2 value, right? I don't need to traverse it again. So we already traversed this path and we already stored the result in our memory array, so we are going to reuse that value. Okay, so like this we can easily solve it. So again I will suppose I will come to 6 here, right? Again from 6 I have 3 paths. I can go upside, that is 9, I can go right side, that is 6, I can go downwards, that is 2. So I already know the result of 9, so we don't need to traverse. We can reuse this value, that is 1, right? Again I can't go right side because 6 is equal, right? It's not greater. Again now the next is 2, so I can go 2 because 6 is greater than 2. So again in this case my value will be 2, that is 6 to 9, the longest value will be 2, so this value will be 2. Correct. And now my matrix will look like this: 1 1 2 2, then all are 0, right? Now again I will probably check for other all the cell, right? So using this way we can optimize our existing approach, and we will save lots of duplicate DFS call, right? So let's try to modify the code and see how we can solve with this optimized approach, right? So my approach will remain almost same, but here we are using some extra memory. So let's declare that first. So we are going to take one extra memory. Let us name it as memory only. So int memory, and size will be new int, and again here m and n, correct? Now what next? So we need to update this result, right? So we already declared this memory. So now we will slightly modify our logic. So we will take one temporary variable here. I will explain why I am modifying it. So let me write fast. So let us name it as temp length, and we will call similar DFS function. And in this case we are not using length. We don't require any length because we are already storing the length in our memory matrix, right? So it will look like this. Then again we will update our, in this case, in this approach we will update our result variable from our main function, that is longest increasing path. So we will write like this: result should be equals to map.max my earlier result or my temporary result, whichever is maximum, that will be my result. Okay, fine. And instead of length we need to pass our memory. So right, whatever memory we need to pass it. So let's pass it as memory. Okay, fine. So these are the changes required in the main function, and let's quickly see what are the changes required in the DFS function or helper function, right? So you can rename it to in different name. So here we are passing memory. Cool. So now in this case we need to return one integer value, right? The temp length. So we will return integer here, and we don't need this line result, but rest of the logic will remain same. So what I will check, so we were checking the this logic, right? We are checking the result, and we keep checking the maximum one, right? So in this case we don't need the maximum one. Instead of that we will check whether we already traversed this path or not. So how we can check? If I see, I will check my memory value, right? So as I told you, suppose whenever I am traversing, so suppose I am traversing from 6, I am in 6, I am traversing to the upward direction, that is 9. Before traversing from 9, I will check that whether we already traversed 9 from our memory matrix, right? So we will write that logic here. So I will check my memory, that whether I already traversed this path I or j. If it is greater than 0, so default value was 0, right? So if I see it is greater than 0, that means we already traversed. So we can return the same value, right? So we can return that same value, that is memory ij. Okay, now what next? Okay, so we will return, if I see that we already visited that path, we will return like this, else this logic will remain same. And apart from this we need to keep checking the length also, right? So this boundary condition, again it will remain same, but this logic will change up to some extent. So what it will look like, it will look like this. So we need to update our memory, right? Instead of returning, we need to update our memory. So it will look like this: memory ij should be equals to map.max, correct? And we will call our next value, else we will check our earlier value, right? So my earlier value will be memory ij. Okay, so then it will remain same like this. And once we are done, and so we can increment our value, and we can return the same. So return plus my memory value ij value, right? Okay, so let's quickly run the code, then I will explain what we are doing here actually. So it's throwing some error. Let me quickly fix it. Okay, so it's not matching, right? So it should not be current length. Instead of that, we should pass our memory, right, as per our method signature. So now let's quickly run the code and see. Okay, now it's giving us expected answer. Now let's quickly see that whether it's compiling for, or whether it's giving successful answer for all the results. Okay, now we can see it's all the test cases are successful. all the test cases are successfully passed. Now let's try to understand our logic, what we are doing here. So let me copy the code quickly. So this is our code. Let me go back to OneNote. Okay, so let me paste it here. Fine. So this is what our code, right? So as I told you, so this was our example, right? 9946. Okay, so let me copy it also. Just give me a second. Yeah, so this is our, so what we are doing here, we take one memory, so that is a similar array, m cross n array, and initial value all over 0. Now this is our result variable, so this is our age condition and this is our result variable, right? Now we are just again running same logic, we are picking one cell at a time. So we will start with this cell, and again we are calling our DFS function, and this our DFS function will return some length. Okay, and whatever that length, I am going to store that in our result length if it is larger than the earlier length. Okay, so my initial length is 0. Suppose I am starting from 9 and my initial length is 0, so I will call DFS from 9. So for the 9, everything is for the first time, right? Every value is 0 here, so I can check this value. We are checking this value initially, right, using this logic, if my memory is greater than 0 or not. So that means we have not traversed this particular path earlier, this is the first time. So we will come here and we will try to traverse in 4 direction, right? Similar direction, right? 4. We can go right, top, down, left. Okay, now after that again we are updating our memory. Why this? So suppose I am traversing 4 direction, right? So from 9 we have actually 2 direction, that is from 9 we can go either right side, that is 9, or down side 6, 9 and 6. So whatever my 6 value, this particular left subtree will return. We are updating in our memory, and we are, so basically we know that in base case scenario, from a particular cell we can go to 4 direction, correct, right? So this direction can return one value, this direction can return one value, that is 4 and like 1. So we need to consider all the 4 values, and we need to consider the maximum one. Here in this case it is maximum, so at max we can have 4 different paths, and we need to consider the maximum path value, right? Increasing maximum value, right? Here it is 3. So to get the maximum value, we are writing this logic, right? So I know from 9 we can have 2 paths, so probably one path can return 1, another path can return 2. So in this case we should consider the largest value, so that we are writing this logic, right? Okay, so like this. So if you check for 9, again for 9 we can't go anywhere actually. So again this condition will not execute for 9, because all the value from 9 are smaller or equals to 9, not greater than 9. Okay, so now again we will return plus plus my earlier value. So my earlier value was 0, and now since we are not able to traverse anywhere, so it will return 1. So now I will update my memory matrix, and it will be now 1. So that means from 9 we can't go anywhere, so length will be 1, because we are not able to traverse anywhere. So similarly we can check it for 9, again for second 9 also, right? For second 9 we have 3 options, right? We can go downwards, that is 6, we can go right side, that is 4, we can go left side. So there is no point to traverse left side, it is equal. There is again no point to traverse right side, it is smaller, 6 is also smaller. Now again I will come to 4. So whenever I will come to 4, I have again 2 options. I can go downwards, that is 8, or I can go left side. Okay, so whenever I will go left side, right? 4 to 9. I already traversed 9, correct? This value was 1. Okay, I already traversed 9. So I am not going to traverse it anywhere. I am going to I will return. So if I draw the tree, right, recursive tree, from 4, I have 2 options, 9 and 8. I will come to 9. Okay, and we are traversing all the possible path from this line only, right? So again I will traverse 9, and in this case it will return 1, because we already traversed 9. So my current value will be 2, right? 4 plus 9, 2, correct? Sorry, it will 1, right? Initially it will be 1 for the left side path. Now we will check it for right side. Okay, so right side will give us some value. Okay, it surely give us some value, and out of this whichever is maximum, we are going to considering that value in our memory, and later we are going to increment that value. Okay, so whenever we will return it for 4, it will return 2. This value will be 2. Okay, so here my max will be 1, and we are incrementing by max here in the last line, right? So it will be 2 plus 1. So using this approach, if you can dry run for all the cell, you will get the answer. Okay, I think that's pretty much for this video. And if you like this video, you can subscribe to our channel, and if you still have some doubt, you can ask me in the comment section. Thanks for watching. Bye bye.